Well, I've now finished the Aeropack 98mm retainer as planned. So I used good old McMaster Carr 832 taps, and I got the matching drill bit from them, and I put in all of these screws with the hex wrench, and it always takes a little while to get them lined up when there's so many, but I just put them in gently, and then crossing over just like you put in a spare tire, going back and forth so they would stay on track. And then a couple of them I had to re-drill it, touch it up a little bit, and then tap it to make sure they fit. Then I put in some thread blocker. I got this thread blocker red, which has actually lasted for 5 years of rocketry. It's a lot in there. So I put that in the threads. I certainly wouldn't want this to come out, and I tightened them down really well, because you certainly wouldn't want a big heavy motor to slip out of there at any point during the ascent or descent. And yeah, that works really nice. And this just screws on here. I got a nice retainer, and then that will go over here on the rocket. All right, so I've got these threaded rods. They are 1/4 inch diameter, 24 inches long, and what I'm thinking is that I'll put 3 holes in each of these centering rings and then position them like that just for extra strength inside that motor mount area. And then also my next step is gonna be this anchor for my harness, which I mentioned before is using an Aeropack minimum diameter 98mm plug. But what I've done though is added a bolt onto it just for extra safety, because typically on a 6-inch fiberglass rocket I'd use a U-bolt to make sure that it's extra secure, and so that if it's when it's spinning down during the recovery that it doesn't spin out. And to position that correctly, I'm gonna put in this this is a 5-grain 75mm motor. This is loaded with an M1401 right now, which I'm not planning to put in this rocket right away. I first fly it several times on a K motor and L motor, make sure that it's a good solid rocket. But maybe someday I want to use an M motor. This is loaded up for another flight, but I just want to make sure that the sizing would work for a motor of that length if I wanted to. So I'm gonna slide this 5-grain 75mm motor and then mark where the top of it is. I'm not gonna use this, I'm not gonna actually ever use this screwing this in, as I said, because I have a regular retainer on the aft end of the rocket. But I do need to make sure it's high enough above the longest possible motor so that I can use up to a 5-grain motor if I want to. So I've now marked that spot, which is right about here, just to make sure that I'll always be above the longest possible motor that I might want to ever fly in this rocket. And then this Aeropack retainer will then want to go above that line. I'm not going to actually use this threaded part because I don't need to do it as a minimum diameter, but I do need this as a plug, as an anchor, and it goes through that loop just as extra precaution in case this were ever to spin loose. But of course this is this is also going to be threaded in with JB weld as well. And then the shock cord goes up like that. So that'll be on that end, and then you'll have the fin will be right up against that, and then I'll pull this center ring down so the center ring's flush right over here on this left side. And as I mentioned before, these are these nice strong canvas phenolic fins from Mac Performance Rocketry. Mike Krupp kindly sent me those. These are the fins from his 6-inch Mac Black Fly, and I'm just taking that goes like this. I'm just going to reverse it just for a change. But these are nice fins because they're nice and lightweight, but strong and lightweight, which is what I need, because otherwise my fin can will be too heavy if I used like the standard G10 fiberglass fins for a standard, like a standard Wildman Ultimate Series rocket, they're big, strong G10 fins, which is great and all, except that in my case, I don't want too much weight down here because that'll mess up my stability. So these are actually perfect fins for this rocket, and Mike kindly arranged me to get those. So that's all painted. I painted it pretty early on in the process here, but my reason was because I want to have different, I want the fins to be different color than the fin can, and you know, it's just a lot of hassle when you're all done to tape up the entire rocket just to paint the fins. So we'll see. Now I'm gonna have to tape up this part though to protect this bright shiny green, but anyway, that's the plan. So yeah, so this retainer's all ready to go. I'm happy about the way that turned out, and we'll see what happens next with this project. Okay, well, just now I went ahead and epoxied in the minimum diameter retainer right here, and I also put this bolt in with 3/8 inch bolts with a 3/8 inch hole there that I drilled through, and then I put the minimum diameter plug down in there. And if you've done high power rocketry of this sort, you know that the epoxy process is very messy. Even when it's just JB Weld, it's not quite as sloppy as some other kinds of epoxy, but still quite a mess. And I use rubbing alcohol to clean up the workspace and the fiberglass, because I don't want to have epoxy on there. Once the epoxy's cured, it's impossible to get it off of fiberglass. So then we can look inside and see what I did down in there. That is the top of that red Aeropack 98mm plug, and you can see the bolt that I put through the eye bolt on the top of that retainer. That is the extra insurance, just in case somehow that eye bolt got twisted and it popped out, or even if the whole thing, the epoxy, somehow came through. But as you can see, there's a lot of JB Weld down in there. You can see the darkened area, so I don't think it's going anywhere. Then we can also look way down inside the motor mount to see what it looks like from down in there. And that's where it is. So I think that's in a good position, and I think also that it is high enough up in the motor mount that I can put up to a 5-grain 75mm motor if I want to someday. I'm going to start with K's and L's that are shorter. Also, it's low enough in the motor mount so that I can fit all of the harness, which is this 1/2-inch Kevlar, and I've measured that and I think it fits okay. And then just a reminder of the big picture here. So once I have this motor mount done, and I haven't epoxied these, but once I epoxy these in and position them, then this whole airframe / motor mount will slide down inside this 6-inch portion. And then on top of that will be this fiberglass airfoil, which is actually a tail cone from a Mac Performance Rocketry 6-inch black fly, super black fly from Mac Performance Rocketry, but I'm turning it around and using it as an airfoil, so that'll come down on top of this and be positioned like that. And then the top of the rocket will be this payload and av-bay section of my Mad Cow Super DX3, which had a Kato, which was the origin of this whole project, except that I decided to put a 6-inch portion at the bottom just for fun, for a change of pace. So we've completed the bolt and the harness attachment point. The next step will be to put the steel rods through these centering rings. And again, this is not an ideal kind of a design. There's no real reason to do a 6-inch to 4-inch transition. It's not going to be more stable. It's not going to be a better flyer. It's just an interesting design challenge that I wanted to try out for fun. So that's what I'm doing, and hopefully it will work.